Good day, everyone! Welcome back to Mathematics 9 video tutorial, and we are now in our Quarter 1, Week 2 to 3, entitled Solve Equations Transformable into Quadratic Equation, including Rational Algebraic Equation. And we have the following objectives. The first one, transform quadratic equation into the standard form ax squared plus bx plus c is equal to 0. And the next one, find the solutions of equations transformable to quadratic equations including rational algebraic expressions. There are equations that are transformable to quadratic equations. These equations may be given in different forms. Hence, the procedures in transforming these equations to quadratic equations may also be different. Once the equations are transformed to quadratic equations, then they can be solved using the different methods of solving quadratic equations, such as extracting the square roots, factoring, completing the square, and using the quadratic formula. An extraneous root of an equation can be derived from an original equation. However, it is not a solution of the original equation. So we have example number 1. Solve the rational algebraic expression 6 over x plus x minus 3 over 4 is equal to 2. So we have the following steps on how to solve that equation or rational algebraic equation. So step number 1, multiply both sides of the equation by the least common multiple or the LCM of all denominators. So the denominators are located at the bottom of this equation. So we have the x and 4. So in the given equation, the LCM is 4x. Since our denominators are x and 4, we're just going to multiply this two denominator. We will get now the least common multiple of this equation. So we have now going to multiply those LCM, which is 4x, to our equation. So we have 4x on the left side. We have also 4x on the right side. So let's start. For this one, we're going to use the distributive property to simplify this equation. So we have 4x multiplied to 6, that is 24x, divided by x, cancelled all the x, we will get now the 24. Next, 4x multiplied to x, that is 4x squared, divided by 4, we will get the result x squared. So we have 4 divided by 4, that is 1, and if we multiply x to x, that is x squared. Next, 4x multiplied to negative 3, that is 12x. So 12x divided by 4, that is 3x. And we have here the sign negative. So for this one, 4x multiplied to 2, that is 8x. Next, step number 2. Write the resulting quadratic equation in its standard form. So our equation a while ago, we have 24 plus x squared minus 3x is equal to 8x. So again, our standard form is ax squared plus bx plus c is equal to 0. So let's start first with the exponent of 2. We have x squared. Next, which is the bx, we have here negative 3x and positive 8x. So if we transpose this 8x to the left side, that will be negative 8x. So negative 3x minus 8x, that is negative 11x. And next we have the c, or the constant term, 24. So let's just copy positive 24 and then equate to 0. Next. Okay, step number 3. Find the roots of the resulting equation using any of the methods of solving quadratic equations. Try factoring in finding the roots of the equation. So in our example, I use factoring method to find the roots of this equation. So this will be now the factors of x squared minus 11x plus 24 is equal to 0. So how did we get this one? Okay, so we simply get the multiples or the factors of x squared, and those are x and x. And we put here in our first parenthesis the first x, and another x to the second parenthesis. Next, let's move on to 24. What are the factors of 24 that if we add or subtract, the answer is 11? Okay, so the closest one is the factors 8 and 3. So if we multiply 3 times 8, that is 24. So in order to get this negative 11x, we just put negative as the operations of the two. So if we add negative 3 plus negative 8, the answer is negative 11x. So this will be now the factors of x squared minus 11x plus 24 is equal to 0. And now we're going to equate these two factors into 0. So we have the first one, x minus 3 is equal to 0. And the other one, we have x minus 8 is equal to 0. So for this one, x minus 3 is equal to 0. We just have to add both sides by 3. So the answer will be now x is equal to positive 3. So for this one, we just have to add both sides by positive 8. The outcome will be now x is equal to positive 8. So the roots are 3 and 8. So let us now proceed to our example number 2. Solve the rational algebraic equation x minus 3x over x minus 2 is equal to 6 minus 6 over x minus 2. Okay, so we have the following steps. Step number 1. Okay, multiply both members by the LCD, and the LCD is x minus 2. Okay, let's take a look at the denominators. We have the same denominators. Therefore, this will be now our LCD, or the least common denominator. So again, we have to get the LCD and put it on the left side, also to the right side. So this will be now our equation in step number 1. Next. So in step number 1, let's simplify our equation. So the first one, we're going to have the distributive property. So x minus 2 multiplied to x, that will be x squared minus 2x. Next one, x minus 2 multiplied to 3x divided by x minus 2. We just simply cancel this one and cancel. So the remaining will be minus 3x is equal to, in the other one, again, we're going to use the distributive property. x minus 2 multiplied to 6. So we have x times 6, that is 6x. Negative 2 times positive 6, that is negative 12. And the last one, for this one, we just simply cancel x minus 2 and x minus 2. The remaining will be negative 6. So this will be now the outcome of this equation. Now, let's proceed to the combining like terms. So combining like terms, so let's see, x squared. Is there anyone here who have exponent which is 2? No, so let's copy x squared. Next, negative 2x or 2x. Yes, it has two combined like terms. We have 3x and 6x. So let's combine those three. So since 6x is on the right side, we just have to transpose it on the left side. From positive, it will become negative. So we have now negative 2x minus 3x minus 6x is equal to, and we have now the c or the constant term, and those are 12 and 6. So we have negative 12 and negative 6. Okay, so let's solve. X squared minus 2x minus 3x minus 6x, and that is negative 11x. As you can see, they are all like sign, so we just have to add and get the sign of this 3. And the other one, we have negative 12 minus 6. Again, this is like sign. So we're going to add 12 and 6, and that is 18, and get the sign which is negative. And now, since negative 18 is on the right side, which is in our standard form, the right side will be 0. We just have to transpose this negative 18 on the right side and the left side. From negative, it will become positive. So our standard equation now is x squared minus 11x plus 18 is equal to 0. So again, I use the method factoring to get the roots of our standard form equation. So let's see what are the factors of x squared. Again, x and x, so we put the first x on the first parenthesis and another x on the second parenthesis. Next, take a look on the 18. What are the factors of 18 that if we add or subtract, the answer is negative 11. So we just have only factors, which is 9 and 2. So we put here 2 and 9, or or just simply 9 here, or 2, the same as true. And the next one, we have negative 11. So how can we get that negative 11? So as you can see, we have here negative and negative. So if we add negative 2 and negative 9, that is negative 11. So this will be now our factors. Now, we're going to equate those factors into 0. So the first one, we have x minus 2 is equal to 0, and the other one, we have x minus 9 is equal to 0. So for this one, we just simply transpose this negative 2 to the other side. So we have now x is equal to positive 2. And the other one, we have x minus 9 is equal to 0. Transpose negative 9 to the other side, it will become positive. So we have x is equal to positive 9. So step number 4, check whether the obtained values of x make the equation x minus 3x over x minus 2 is equal to 6 minus 6 over x minus 2. So again, we have the following factors a while ago, we have the first one, let x be equal to 2. So let's just substitute the x here into 2. So we have the first x, we have 2, minus 3x, substitute it with 2, so we have 3 times 2. Next, over x minus 2, and again, this will be 2. And on the other hand, we have 6 minus 6 over x minus 2, and our x here will become 2. So let's simplify. So 2 minus 3 times 2, this is 6, divided by or all over 2 minus 2, this is now 0, and this will become imaginary. And next we have is equal to 6 minus 6 over 2 minus 2. Again, this is 0. So if we divide 6 divided by 0, that will be imaginary. So as you can see, since a zero denominator has no meaning, 2 is not a root of the original equation. Therefore, 2 is called an extraneous root. Because this will be now cancelled. 2 is not equal to 6. Therefore, 2 is not the root of the original equation. Let's now take a look on the other one. Let x be equal to 9. So let's substitute all the x here into 9. So this will be now the outcome. 9 minus 3 times 9 over 9 minus 2 is equal to 6 minus 6 over 9 minus 2. Okay, so we have 9 minus 3 times 9, that is 27, divided by 9 minus 2, and that is 7. So we have 27 over 7. Next, 6 minus 6 over 9 minus 2, that is 7. So we have here 6 over 7. Okay. Now, in simplifying this one, we have to get the LCD. So as you can see, we have the same denominator. So let's get 7 as the LCD, or the least common denominator. So again, we're going to put the LCD on the left side and also to the right side. Now, by distributive property, let's simplify this equation. So 7 times 9, that is 63. Next, 7 multiplied to 27 over 7. Just simply cancel 7 here and then 7 here. We have now negative 27. Next one, 7 times 6. This is 42. And for this one, 7 times 6 over 7. Cancel 7. Cancel 7. We have now the remaining negative 6. Okay, next 63 minus 27, that is 36. And 42 minus 6, and that is also 36. Therefore, our conclusion is the solution set is positive 9. Again, 2 is not a root of the original equation because 2 is called an extraneous root. Okay, so those are the examples of our lesson for today. I hope you learned something or you learned a lot in our lesson for today. So for your activity, let's do this on a notebook or any piece of paper for your practice. And after I read your activity for today, post this at the count of 3, then play it again after 20 minutes. So we have number 1, 5x squared is equal to 3x plus 2. Number 2, 2x squared is equal to x plus 3. Number 3, 5 over x minus 1 is equal to 2x minus 1 over x minus 2 minus 2x minus 7 over x minus 1. Number 4, 1 over x plus 1 over x plus 3 is equal to 1 over 2. Number 5, x over x minus 1 plus 1 over x plus 2 is equal to 3 over x squared plus x minus 2. Again, pause this video at the count of 3 and play it again after 20 minutes for your checking. So let's be honest on checking our own paper. At the count of 3, 1, 2, 3. Okay, so I know that you are done. Let's check your own paper. Number 1, the answer is the solutions are 1 and negative 2 over 5. Number 2, the solutions are 3 over 2 and negative 1. Number 3, the solution is 3. 1 is extraneous root. Number 4, the solutions are 3 and negative 2. And number 5, the solution is negative 4. So that is the answer of your activity.